In trig equations, we'll have a look at more examples. Solve tan of x minus 10 equals 1.2 for x between 0 and 360. Here we've got x minus 10 equals the inverse tan of 1.2. Your calculator will tell you that is 50.2. Quick sketch tells you that the other answer is going to come from 180 plus that, so that gives us 230.2. But that was x minus 10. We need to work out all our different values before we start doing anything with that bracket. So we're looking at x minus 10 equals all these different answers. So we've got x minus 10 equals 50.2 and 230.2. So therefore x is, just add on 10. So x is 60.2 and 240.2. Another example will show you what I mean. Solve sine of 2x equals half for 0 up to x up to 360. Because we've got a 2x here, in order to find our x afterwards, we're going to divide everything by 2. So for our answers to be trapped between 0 and 360, after they've been divided by 2, before they get divided by 2, they should really go for double the range. So because it's a sine 2x, I'm going to double the range. So the range I'm interested in is 0 up to 720. So I can do this just by my sketch very quickly. All I'm doing is drawing an extra wiggle in. That tells me that I'm interested in 4 answers. So to get 2x, what I'm going to do is I'm going to inverse sine of a half. Inverse sine of a half, it's one of our special ones. We should just know what this is to write it down. It's just going to be 30. Our other answers are going to be 180 minus 30. So that's 150. We're going to do 360 plus 30. That gets us into that second wiggle. So that's 390. And the next one's going to be 540 minus 30. So that's going to be 510. But all of that was 2x equals all of them. So 1x is just half everything. So x equals 15, 75, 195 or 255. Another example that we can do with trig is we can start using trig with quadratics. For example, solve sine squared theta minus sine theta equals 0 for theta trapped between 0 and 360. Well, I can't do anything with it like that, so I'm going to have to factorise it. Some people prefer to change it into something before they factorise it. Some people like to write it as an s rather than sine theta, just because it saves on writing a little bit. I'm just going to write it as sine theta. So I've got two things times together equals 0. That tells me that either one or the other of them is 0. So I get my answers from sine theta equals 0 or sine theta equals 1. So it's the solution of the brackets. Sine theta equals 0, have a look on my sketch. I've got 0, 180 and 360. Quick check for my range, it was inclusive with the 0 and 360, so both of them are allowed. Sine theta equals 1 on my sketch, very easy to spot that that's just 90. So all my answers are written there for me. Some people like to write them out in ascending order. I'm happy with them like that. So running with this quadratic trig idea, we'll do another example. Solve tan squared theta minus 3 tan theta plus 2 equals 0 for theta trapped between 0 and 360. Again, people like to substitute t instead of tan theta. I'm going to run with tan theta. I can factorise this quite easily. Tan theta times tan theta is tan theta squared. To make the plus 2 and the minus 3, it's got to be a 1 and a 2, and they've both got to be minus. That gives me two sets of solutions. Tan theta equals 1, tan theta equals 2. Looking at the tan graph, I know if I get one answer, I just add 180 to it. So theta equals inverse tan of 1. Again, it's one that we should know, 45. The other answer is just going to be 45 plus 180, so that's 225. Tan theta equals 2, we're going to have to ask the calculator, 63.4. So for the other answer, I'm going to do 63.4 plus 180, which is 243.4. Another example that we can do in trig is finding maximum and minimum values. If you think about your sine and your cos, they have got maximum and minimum values. So any transformations we do thereof are still going to have maximum and minimum values. So we'll look at this example, find the maximum min values of f theta equals 1 minus 4 sine theta. Well, your maximum and minimum values of sine are going to be 1 and minus 1. So the maximum minimum values of your function are just going to be from subbing in 1 and minus 1. We take them both individually. Look at the first one, 1. 1 minus 4 times 1 is minus 3. 1 minus 4 times minus 1 is positive 5. So it tells us our minimum is minus 3 and our maximum is 5. Alternatively, you could have drawn a sketch of that function just by doing your transformation knowledge. Thank you.